Today's wildcard is very exciting. It comes from sequences and series. It's a very complicated sequence and series that involves sigma notation. So let's jump right into it and see what the story is with this particular question. Right, so it reads as follows: calculate. All right, if you look there, it looks very funny. Anybody who's not in grade 12 will never, ever understand what is the funny thing that you see there. What is with all these E's that you're looking at? First of all, that is not an E. That is a Greek letter S. It's capital letter S, which is sigma. This is famously known as the sigma notation. Now, in our sigma notation, there's two of them. Very important for you to pay attention to that. We need to calculate. The examiner just says calculate. The most important thing you need to understand when you're dealing with sigma notation is two things. Number one, you need to know that they're asking you to find the sum. That is very important. That is what the question is essentially about. We want you to calculate the sum of what you're looking at. Number two, you can only find the sum if you do what? If you expand. So I'm going to expand the terms and then I'm going to add them. So you must find the sum after expanding things. So we're going to expand and then add the terms. Right, please keep that in mind. Okay, now the first part here, because they've got two of them, allow me to put the plus sign in the middle and say there's the first sum here, which I'm going to put here, and there's going to be a second sum that I'm going to put on the other side. Very important for you to keep that in mind. Now, according to the sigma notation, we know that we need to substitute our t by the exponent that you see there and increment our t values by a 1 until we get to the top number that you have there, which in this case happens to be infinity. So I'm going to write this as 3 over 2 to the power of 1, right? Very important. Plus 3 over 2 to the power of, our t changes now to a 2, right? Plus 3 over 2 to the power of 3. And this can go on and on and on until the second coming. Right. And then that's the first part. We need to go all the way to infinity, so I don't know where it's going to end. The second part is very exciting because it's only a constant, right? So I want you to understand something very important. A lot of people don't understand how to handle the sigma of a constant. The sigma of a constant is just that constant multiplied by how many it needs to appear. So this is 5 plus 5 plus 5 plus 5 plus 5 n times, right? Very important for you to keep that in mind. Now, this is simply going to become, because it's a constant, there's nowhere to put that particular t value from minus 5 all the way up to 5. So it's going to be the first 5 that I'm going to get when I put t as minus 5 plus the second 5 I'm going to get when I put t as minus 4 plus the second 5 that I'm going to get when I put t as minus 3. I'm busy imagining the substitution of t as those t values that are acceptable until I get to a point where I substitute my t as 5. So this has to be 5's n times. Please keep that in mind. It's 5n times. Okay, cool. Now, what you're looking at now is very exciting stuff right there. So term 1 is 3 over 2. Term 2 is 3 over 4. Term 3 is 3 over 8. So we've got 3 over 2 plus 3 over 4 plus 3 over 8 plus and so on and so on. All that needs to be added with 5 times n, right? 5 times n times, right? But how do you work out your n? How do you work out how many n values are here? The algorithm for working this n value, beautiful people, will always be n equals to the top number that you have there. So it's going to be the top number minus the bottom number where you are starting. So minus the bottom plus 1. This is the algorithm of working out the number of terms that you are adding in a sigma notation question. So the top number in what we are looking at is 5. So I'm actually sitting with 5 minus the bottom number, which is minus 5, and then we need to add 1 at the end. That is 5 plus 5, which is 10 plus 1. So in essence, we are simply adding 11 5s in total. If you look at that, this is actually equal to 11. Right, so this is actually going to be 5 multiplied by 11, because there has to be 11 of those 5s that you're adding. Right, the one on the other side, the left-hand side part, right, this is the sum to infinity. So I'm going to use the formula of sum to infinity, which says the sum to infinity can be given by a divided by 1 minus r. Very important for us to keep that in mind. And then what is my a value? My a value is 3 over 2. So I'm going to have 3 over 2 divided by, what is the number? The ratio here is actually a half. That is actually what you're looking at. Plus 5 times 11, which is simply going to be 55. This is the answer of the second part. Now, on the first part, we're going to call a calculator to assist us to understand what is 3.5 divided by 3, because it's important for you to understand where I got my R from. I got my R by saying term 2 divided by term 1. This is how you always calculate your ratio. So 3/4 divided by 3/2, it gives me an answer of 1/2. So that's where my ratio comes from. Now, that part of sum to infinity is simply, we've got 3/2 divided by, right, 1 minus 1/2, which is 1/2. This gives us an answer of exactly 3. So the answer to this is just 3 plus a value of 55, and we're simply going to have 58 as the solution to this beautiful question. I hope you understand now how do you analyze questions that involve sigma notation, but importantly, how do you handle it if it has got a constant on it. If it has variables, I know you guys are very good at doing that, but if there's a constant, it just means it is that constant added to itself n times, and n will always be the top number minus the bottom number added with 1.